little Morse code.
Yeah.
All right, I'm back.
Can you hear us now?
Yeah, I can hear you now.
There we go.
Yay.
There you go. You could hear me from the beginning or no?
Oh yeah.
Yeah, we could hear
Yeah.
you.
I couldn't
yeah.
hear you.
We tried to talk to you. It just sounded like you were
That's
ignoring
perfect.
us.
Maybe
being
I
all
did it.
super
Maybe I
rude.
did it on purpose. Okay.
Real quick before these questions, I know I asked a question on homework, but on the test, I know some people's grades got changed. Will you be adding notes to the test about where we messed up in my math lab?
Yeah. Well, I put what I put, gave partial credit on and all that. But if you have a question over the numbers that I wrote, then let me know. Because
Okay.
I know I did take off credit for problems you didn't show work on. Because remember, I mean, I wanted you guys to show all your work, and for some of the domain problems, nobody showed anything. So if you use the graph, if you use an XY chart, if you used anything, show me what you used other than just writing an answer down.
Your notes on the test 1 grade or the test 1 upload grade?
They are on the test 1 upload.
Okay. Okay, perfect.
Yeah. You'll just see my little comments. You'll see
there it is.
I gave partial credit, full credit, or I took points away for no shown work.
And then on the test, are we able to review it again? Because I don't have nothing in there. I can't see the test.
The only way to that's a good question. The only way to review it is to actually go to my mathlab.com.
Okay, great. Perfect.
Yeah. So that's the only way to go look at it again, is to go to my mathlab.com.
Okay, awesome. All right, that works for that. I can go back and review what I did wrong.
And then I saw there were questions in the chat. Let me see. Let's see, y'all were having fun, huh? Morse code. Number 12 on 5-1, and then number 8. Okay. So today we have long division of polynomials. So basically, we're going to divide 2 polynomials. And first, we must write the polynomials in standard form and fill in any missing powers of x. So we're going to make sure all powers of x are accounted for before we even set up for long division. And then the final result in long division should be a quotient plus a remainder over a divisor, just like regular long division. Those are always your results: quotient plus remainder over divisor. Okay. So let's go ahead and start with the first one. And I'm going to put some labels on our polynomials. So the first polynomial, this is called the dividend. This is what's going to go inside our division symbol, or you can call it a division box. And then this x squared plus 1 is, of course, our divisor. Okay. But before we begin, we always want to check the dividend to see if there's any missing powers of x. And it has to go in order. So here we have x cubed, x squared, and x to the first. And if you want, you can say 7 is x to the 0th. So we have 3, 2, 1, 0. So we see that we have no missing powers. If we are missing a power, we would have to fill it in. Okay, but this is good to go, which means we can set up for long division. So when you set up for long division, the first thing we put is the divisor. X squared plus 1. And the next thing we draw is our division symbol. And inside this symbol goes our dividend. 3x cubed plus 4x squared plus x plus 7. Okay, and our goal is to break down the dividend. And there's a little trick, because if you're wondering what to multiply by to get rid of the first term, well, the trick is, and I'll put it under side work, you take the leading term of the dividend and you put it over the leading term of the divisor. And what this will tell us is what we should multiply by. So we put 3x cubed over x squared, and we're going to end up with 3x. This means that in order to get rid of this first term, we need to multiply the divisor by 3x. And I'm going to put it above the x. So this is what we're going to multiply by, 3x. So in my side work section, I'm going to do 3x times x squared plus 1. And that'll give me 3x cubed plus 3x. Okay. So now, when we set up for our long division, I'm going to put what we just found in our side work section. 3x cubed. I didn't get an x squared term, so that means I'll just put a plus plus, just a spacer there. 3x cubed plus 0x squared plus, and I'm going to put the 3x here, and there's nothing else after that. Okay. Now, inside your division symbol, the operation is subtraction. So we are subtracting these terms. So now we start 3x cubed minus 3x cubed will cancel. And then 4x squared minus 0, that 4x squared will come down. And then here's where we have to be careful with our signs. 1x minus 3x. What will that give me?
Negative 2x.
Good. Negative 2x. And then the 7 comes down. Everybody good with that? Okay. And now we have to know if we can go further. So we ask ourselves, can x squared divide evenly into x squared? And the answer is yes. So again, if you need to do the trick, if you're wondering what should we multiply by again to get rid of the 4x squared, well, once again, if you use the trick, leading term of dividend over the leading term of the divisor. So 4x squared over x squared means we are going to multiply by 4 to help us get rid of that 4x squared. And I'm going to put that right here, plus 4. Okay. And then I'm going to multiply the 4 times our divisor, and we get 4x squared plus 4. Okay. And that's going to go right underneath our dividend. 4x squared. We didn't get an x term, so you can put a little spacer there. And we got a 4. And still, the operation is subtraction. So your 4x squareds will cancel. Negative 2x minus 0 is still negative 2x. And 7 minus 4 gives me 3. Okay. Now, can we keep going? Does x squared go into x?
No.
No. Technically, no. So this means we are done. We can't break down this polynomial anymore. So how we're going to write our answer is whatever's above your division symbol, this is called the quotient. Down here, what's left over is called the what?
Remainder.
And then, of course, what we divided by was the divisor. So our final answer is the quotient plus the remainder over the divisor. And that's it. That is long division. Any questions on that process? So just watch your signs. Okay, let's try it again. B, x to the fourth minus 3x cubed plus 2x minus 5 divided by x squared minus x plus 1. Look at your dividend. Are we missing any powers?
No.
Squared over the 2x.
Good. So we have 4, 3. We're missing the power of
2.
2. So we have to say plus 0x squared plus 2x minus 5. We always have to account for missing powers. That's the only way to do long division without messing it up. So now we have 4, 3, 2, 1, 0. We have all powers accounted for now. Divided by negative x squared plus x plus 1. Okay. Which means let's go ahead and set up. So we'll have our divisor, x squared minus x plus 1. Different color. Division symbol, and in goes our dividend. Okay, and now I'll just keep showing you for our side work. To know what to multiply the divisor by, to break down the leading term of the dividend, we put x to the fourth over x squared, and that's going to reduce to x squared. Okay, so that means x squared will go there, and now multiply the divisor by it. You'll get x to the fourth minus x cubed plus x squared. X to the fourth minus x cubed plus x squared. Okay, and then your x to the fourth will cancel. And now here's where we have to be really careful. Negative 3x cubed minus x cubed. What's that gonna give me?
4x cubed.
So listen to it again.
Wait.
Negative 2x cubed.
There you go. Because it's negative 3x cubed minus x cubed. Where minus turns plus. So there's our negative 2x cubed. And then 0x squared minus x squared. What's that going to give me?
Negative x squared.
Negative x squared. and everything comes down. Watch your signs, right? Okay, now let's do it again. Leading term of dividend over leading term of divisor. Negative 2x cubed over x squared gives me negative 2x. That's what we are multiplying by. Okay, and then negative 2x times x squared minus x plus 1 is going to give me negative 2x cubed plus 2x squared minus 2x. Okay. Negative 2x cubed plus 2x squared minus 2x. Okay, and now we know the leading terms will always cancel. Gone, gone. And now again, be careful with your signs.
Wait. Professor Carrillo,
What's up?
isn't that a negative negative? Wouldn't we be adding that 4x cubed?
Very good question, because it's negative 2 minus minus 2. So minus minus will turn,
Positive
which will give me
4x cubed. Oh, excuse me, negative 2 plus 2. Sorry, my
Got it.
bad.
You're good. No, that's a good question. Very good. That's why I say be careful with your signs. And if you're doing long division, those first terms should always cancel out. Okay. So those cancel. And now, once again, be careful. Negative x squared minus 2x squared. What do we have?
3x squared.
Good. Negative 3x squared. And then 2x minus minus 2x.
4x.
There you go. There we go. Okay. Almost there. Because now x squared can definitely go in to x squared. So if you needed more side work, we'd have negative 3x squared over x squared, which would give me negative 3. And then it'd be negative 3 times x squared minus x plus 1, which would give me negative 3x squared plus 3x minus 3. Okay. And now your leading terms will always cancel. And now what are we left with?
X minus 8. Or x, excuse me, x minus 2.
X minus 2. Good, because that's negative 5 minus minus 3, which becomes negative 5 plus 3, which gives me negative 2. And that means we're done there. X squared cannot go into x. So once again, we have our quotient, remainder, divisor, which means we can write our final answer as x squared minus 2x minus 3 plus x minus 2 over x squared minus x plus 1. All right, Not bad. Any questions on that one? All right, then. Let's keep moving. All right. C, 4x cubed minus 3x squared plus x plus 1 divided by x squared. Are we missing any powers of x?
No.
No.
No. Beautiful, then. That just becomes x squared. And in here, we'll have 4x cubed minus 3x squared plus x plus 1. And what could we multiply by to get rid of 4x cubed?
4x.
Just 4x. Good. And fair enough. 4x times x squared is 4x cubed. Subtraction. Leading term cancels. Everything else comes down. And then what could we multiply to get rid of negative 3x squared?
-3.
That's it. Negative 3. Negative 3x squared minus leading terms cancel. Everything else comes down. And now we know that x squared cannot go into x, so we are finished. 4x minus 3 quotient, x plus 1 remainder, x squared divisor. All right. And then we have 4x minus 3 plus x plus 1 over x squared. All good?
I think so.
Got the hang of it?
I make no promises, but I think so.
All right. Okay. Again. 5x to the fourth minus 3x squared plus x plus 1. Are we missing any powers?
We're missing a cube root.
Cube. Just a cube. Plus 0x cubed minus 3x squared plus x plus 1. 4, 3, 2, 1, 0. Divide x squared plus 2. Okay. Now set up. X squared plus 2. Division symbol. And 5x to the fourth plus 0x cubed minus 3x squared plus x plus 1. And now, what could we multiply by to get rid of 5x to the fourth?
Five x squared?
That's it. 5x squared. We didn't get an x cubed and then 10x squared minus, there we go. And then This will be cancel, cancel. Since we didn't get an x cubed, that's gone, that's gone. And now -3 minus 10. What's that?
13x squared.
Good. -13x squared plus x plus 1. Okay. And now, what can we multiply by to get rid of -13x squared?
-13.
-13. And then -13 times x squared plus 2. -13x squared. We don't get a middle term of x. That's -26. So plus, and then -26. I could just say plus still. Keep that blank space there. Okay. And then cancel, cancel. Your x comes down. And then 1 minus -26. What do we have?
-27? Oh,
Plus
yes,
27.
Plus 27. There we go. And that one's done. Quotient, remainder, divisor. (5x squared minus 13 plus x plus 27 over x squared plus 2. There it is. Ooh. All right. All good? Okay. Okay. All right. I think this is the last one. Okay. X to the 5th minus a to the 5th divided by x minus a. Now, what powers of x are we missing on this one?
4, 3, 2.
Mm-hmm. Plus 0x to the 4th, plus 0x to the 3rd, plus 0x to the 2nd, plus 0x minus a to the 5th.
Do we need to do that for the A as well?
We do not. Good question, because a is just a number. X is our variable. Divided by x minus a. Okay, now let's set up. This is going to be a great one. X minus a. And we get x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus a to the 5th. Ooh la la. Now, let's have some fun. What could we multiply x minus a by to get rid of x to the 5th? Same tricks here, nothing different. Leading term over leading term. X to the 5th over X gives me what? X to the
X to
4th.
the 4th.
Good. Then X to the 4th times X minus A gives me X to the 5th minus AX to the 4th. Okay. Let's see what happens. And like always, your leading terms cancel. And now here, be careful with your sign. 0 minus AX to the 4th. What's that going to give me?
AX to the 4th.
Positive AX to the 4th. And now everything is coming down. And let's do it again. Leading term over leading term. AX to the 4th over X will give me AX cubed. Oh, I forgot to put what we're using, right? I said X to the 4th. So that goes there. And then this is going to be AX cubed. There we go. All right. And then AX cubed times X minus A will give me AX to the 4th minus A squared X cubed. So many
X
letters.
cubed or X squared?
What did I say? Oh,
Cubed.
my bad. I keep writing 2s instead of 3s. All right. X to the 4th minus A squared X cubed. And leading term cancels. And next, once again, 0 minus A squared X cubed will leave me with
A squared X cubed.
A squared X cubed. Everything else comes down. Oh, man. No numbers yet, right? All right. And then do it again. Leading term over leading term and A squared X squared. That's what we'll have above. Okay. Which will give me A squared X cubed minus A cubed X squared. So A squared X cubed minus A cubed X squared. Okay. And like usual, cancel, cancel, and that'll turn positive. So now you have A cubed X cubed and bring the rest down. How we doing? Nothing new, right? Just a bunch of letters. Nothing but letters.
Yeah.
Okay, back to red. And now a cubed x squared over x gives me a cubed x. And then a cubed, oops, a cubed x times x minus a cubed x squared minus a to the 4th x. A cubed x squared minus a to the 4th x. Cancel, cancel. Positive a to the 4th x minus a to the 5th. Almost there, guys. A to the 4x over x gives me a to the 4th. And a to the 4th times x minus a gives me a to the 4th x minus a to the 5th. And wouldn't you know it, cancel, 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 and my remainder is just 0. Yeehaw. This is high school division. This is middle school division. And now we have our quotient, x to the 4th plus ax cubed plus x squared, a squared x squared plus a cubed x plus a to the 4th. And since there's a remainder of 0, there's no need to write 0 over x minus a, because that is just 0. So this is our final answer. And believe it or not, that is the formula on how to factor a difference of fifths. So you know how we know how to factor a difference of squares, a difference of cubes. We even know how to factor a difference of fourths. But never would we imagine how to factor a difference of fifths. Well, there it is right there, guys. That is the formula to factor a difference of 2 terms raised to the 5th power. Insane, I know. Okay. Well, that was long division. So if you have any questions, ask away. If not, we are done.